Hi guys, this is Mrs. Gastler, and in this video we're going to talk about vertical projectiles. To begin with, we're going to talk about what a projectile is. And a projectile is something that has been launched, something being a particle, a ball, a projectile, whatever, something that is launched with an initial velocity. Initial velocity means that we're throwing it, pushing it. I don't know what we're doing. We're not just dropping it, okay? And we're talking about vertical projectiles, which means we are throwing it either straight up or straight down. But these things that we're talking about also apply to things when we just drop it straight down too. And so although we were doing that previously, but we're going to be throwing it with an initial velocity. This is a special case here. And so one of the things we need to talk about briefly, though, is objects that are in something called free fall, which we kind of touched on this a little bit before. We say that something is in free fall if it is under the influence of only gravity, okay? And that means that there is no air resistance. In reality, this never happens, at least not on Earth. You have to go out into space in order for there to be no air resistance, because there aren't any places on Earth where there is no air, except a vacuum chamber. And even in a vacuum chamber, there's a little tiny bit of air. So this never actually happens. But in most situations, many situations actually, we can reduce the effects of air resistance enough that we can model free fall easily enough. Okay, so in reality, there is not free fall on the surface of Earth in regular everyday situations, but there is, I'll make a note here, many situations are like free fall. And here's your new, we should have put this in the vocab words, because air resistance is, here's your new makeshift vocabulary word, negligible. It's even fun to say, negligible. Negligible means it is so small you can ignore it, okay? Now, later on, we'll actually talk about air resistance and in situations where it's not so small you can ignore it. And you can think of situations where air resistance is definitely not so small you can ignore it. But in many situations, it's like it's in free fall. Like if I drop this pen, it's not actually free fall, but it's so small that was pretty much free fall, okay? So we're going to pretend that a lot of things are in free fall, even though they're not. And that's totally okay. Gee, it's a good thing I'm not in a new teacher. Okay, so here's what we're going to do for vertical projectiles. Okay, so we have these kinematic equations that are on your, equation sheet, and they look like this sort of on the equation sheet. So we have 1/2 AT squared plus V. I'm going to leave some of the subscripts off, and we've got this one, which would look like this. This one's actually not on the equation sheet, but that's what it would look like if it were, because they use a lot of the delta x things. And I think they leave the f's off, don't they? VF squared equals V naught squared plus 2a delta x. And I was using D instead of delta x a lot because that's too many letters and I'm lazy. It's fine. So in a situation where we're talking about an object that is a vertical projectile, in these situations, the acceleration becomes this thing called the acceleration due to gravity, because gravity is the only force that's acting on it, which we'll talk more about forces later, but it's the acceleration due to gravity. Now, you can't just call it gravity, but you have to say the whole thing, acceleration due to gravity. That's a whole set of words that you have to use, okay? And that value is, you either say negative 9.8 meters per second squared, or you have to include the word down, okay? And this is only on Earth. So if it says you're on Pluto or some unknown planet, then it's going to be another value. And it is totally okay to use -10 meters per second squared. It's up to you which one you choose. And we use the letter G instead of A. And so you could replace every single one of these A's with G. Okay. So the thing that you need to know about that is that because of this downness, you need to make sure that your signs match. Make sure your signs match, because we can throw things up or down. Okay. If V naught is up, okay, and G is down, then your signs should be here. Arrow signs should be opposite. And if V naught is down and G is down, then they should be the same. Signs should be the same. Now, in this situation, you pick if they are both positive or both negative, okay? That one is totally up to you. If you're shooting it down, you want to pick down to be positive, then down is positive. It's up to you, okay? Down can be positive. Okay, that is totally fine. Now, when it comes to vertical projectiles, there are some great things that are patterns that are useful to note. Make sure I'm in the window there. Patterns, okay? All the other patterns with accelerated motion, like your increase in distance, the exponential stuff, and how your velocity changes and whatnot is useful, but there's some great symmetry going on here. And so we're going to look at that for a second. So now remember, we have an object that is being thrown up, or, well, we're going to look at the ones going up, because if you're throwing it down, it's just going down, right? So we're going to launch it up with some initial velocity, okay? And as it goes up, it's going to slow down and stop. So there's going to be a velocity here that is 0, okay? It's going to stop. And then it's going to start going back down and speed up. And when it gets back to the same spot, it's going to have the same speed. So I'm going to draw this arrow exactly the same length. And we'll call this VF. It's going in the opposite direction, okay? So if I were to make these little vectors with their little vector notations, V naught, the value would have the opposite direction. I would write it like that, okay? These would look like that. They're in the opposite direction. So at the same height, they have the same speed. We'll draw a little arrow there. Same speed, opposite directions. And that is a useful thing to know. So, and another thing that you could look at is a graph of V versus T, and this is the velocity here, would have a value, V and VF, this would be minus, right? And so if I'm following here, we'll pretend that goes all the way down right there, it's the same value, right? And this is the point where they stop. What is the slope of this line? Well, in a perfect world, this is going to have a slope of -g, which that 9 point out, okay? Now, this is a graph of velocity. What do you think a graph of speed would look like? Okay, so that's something for you to ponder, okay? And then you could think about what the distance versus time would look like, and also what do you think it would look like if we threw it downward, okay? And what do you think it would look like if we threw it downward or just dropped it? There are all sorts of things that you can look like or think about what those would look like. So that's it for vertical projectiles. If you have any questions, make sure you ask your teacher, which is me. All right, thanks for watching.